Monday, and welcome back. This is 6.3. We're going to be talking about logarithms. We're going to understand how to go back and forth between a logarithm and exponentiation, and also how to evaluate logarithms for this particular section for day one. So first of all, solving the equation 2x equals 8 and 2 to the x equals 8. In this particular case, on the left, we would use the inverse operation of multiplication, right? Because this is 2 times x. And so we would divide x on both sides because division is the inverse operation of multiplication. It would kind of undo that, right? So x would equal 4. Well, what do we do over here when this is 2 to the x power? So the operation here is called exponentiation. So it's an exponent. So it's called exponentiation. To solve that equation, you need an inverse operation for exponentiation, okay? So to what exponent would you raise the base 2 to get 8, okay? And so a logarithm here is the inverse of an exponentiation. So think about logarithms and exponentiation inverse operations. So when you see 2 to the x power equals 8, that's an exponentiation. A logarithm written in this form, log base 2 of 8 equals x, that's called a logarithm, and we're going to talk about that here today. Okay, so those are inverse operations. Okay, kind of think about that. So we're going to use logarithms to solve equations that have variables in the exponents. And we're going to use exponentiations to solve logarithms. Okay, so here's the general concept. The exponential form shows a base a raised to an exponent that equals my result, okay, c. In logarithm form, it shows that the log of the result, so c here, with a given base, so the same base a right here, they have the same bases, equals my exponent. So my logarithm is always equal to my exponent. So you kind of keep that in your head. I always like to remember that. So my logarithm equals my exponent. They always have the same bases, okay? And then this right here, they often refer to as the argument or the result for c, okay? So here again, they're inverses, and to rewrite them, just remember that my exponent, my logarithm is always equal to my exponent, okay? They always have the same bases, so log base b, or my base of my exponent here, and then my result is just always the same here, okay? Remember that my x has to always be bigger than 0, and my b has to be always bigger than 0. My exponents can kind of be anything, right? But the other ones have to be greater than 0. Okay, so we're going to learn how to go back and forth between a logarithm to an exponential function back and forth. So first what I want to do is identify my base. So my base here in this case is 5, right? My result here is my y, and my exponent here is, of course, my x. It's my little green x there. So to rewrite this, we're going to say log, and we're going to use my base, and my base, remember, is my 5 because it's base there, so log base 5. And always, in a way, when I first started doing this, I'd say, well, it always equals my exponent, so always going to equal x. And then what's left over is my argument. Okay, and so that's always my log base 5 of y equals x, and now I have it in logarithm form. Okay, let's do it again. What is a logarithm of 3 to the 4th power equals 81? Well, first of all, I want to identify what my base is, right? What is my exponent? And then what is my end result here, okay? Then I can write this as log base 3. And then, of course, that always equals my exponent. So I kind of like to just write that equals my exponent. And then my argument goes right here, 81, okay? And 3 to the 4th does equal 81, right? And this says the base 3, it has an exponent of 4, equals 81, okay? All right, so what is the exponential form of log base 10 of 1000 equals 3? And so in this case, we're going to write the exponentiation form, the logarithm, exponential form, I'm sorry, this should say exponential form down here. That kind of confused me for a second, I didn't change that. Okay, so this time my base here is my log base 10, okay? My exponent, remember, is always equal, my logarithm is always equal to my exponent, so that's my exponent. And then my result, or my argument in this case, is this 1000, okay? So we're going to write this now in an exponential form. So my base 10 to the 3rd power, that's my exponent, equals my result, which is going to be my 1000 right here, 1000, okay? So my exponential form is 10 to the 3rd equals 1000 up here, okay? That's how we go back and forth. Okay, so now you might want to try this on your own and then turn back on the video and see how you're doing. I highly suggest you do this because this is probably the key part of this whole next chapter, is being able to go back and forth between these logarithm and exponential functions. Okay. Okay, so here we have our base here is going to be 7. We have our exponent is 3. We have our result is going to be 343. Whoops, I changed my colors there. My result is 343. I did something wrong with my base. There, my base should be orange. There we go. All right, so we have log base 3 of 343 should be equal to my 7, right? Where's my exponent? There we go. No, 7. Oh, 3. Sorry, my exponent 3. Oh, I'm sorry. Where's my base? Where's my exponent? There we go. Yeah, I got it. I got it. Okay. Did I write my base wrong? My base I wrote wrong. I'm sorry. It should be 7. I got my numbers and colors mixed up there. Log base 7. Here we go. 343 equals 3. Sorry about that. Okay, next one. What's the exponential form of log base 4 of 16 equals 2? So now this time we have our base is 4. Our exponent, so it's always, our log is always equal to our exponent. Okay, and our result is 16, or argument. Okay, so in this case here, our exponential form is going to be 4 to the exponent, so squared. Didn't change colors there. All right, squared, there we go, equals my result, which is 16. Okay, and there you go. All right, so now let's start talking about evaluating logarithms. So what does this logarithm equal to? So what you want to do here is you want to say, what does this equal, right? Think 5 to what power equals 125. So that's kind of, when I'm going using logarithms, that's kind of a pattern we go to, right? By base 5 of the x exponent equals 125. So I rewrite that, 5 to the x power equals 125, right? Well, I can rewrite this 125 as 5 to the x equals, and then this is 5. I'm going to rewrite 125 as 5 cubed, okay? Well, once I know that my bases are equal, then I know that my exponents must be equal, right? So this now, x equals 3. And so that must be the third power. Okay, so logarithm 5 base 125 is 3. Okay, so I can even rewrite this and say log base 5 of 125 equals 3. This 5 cubed is 125. Okay, so let's go ahead and let's evaluate another one. So same thing here. We want to find out, what does this equal here? Okay, what does this evaluate to? So you have to think 1/4 to what power equals 16, right? So we know 1/4 to what power equals 16. Now I'm going to kind of use some manipulation so I can get those. Our goal is to try to get those exponents equal to each other and have our bases the same. So I'm going to bring this up and say 4 to the negative 1, and of course it's still x there. Okay, so 4 to the negative 1. And let me write that a little bit differently so it looks a little bit more like what you're used to seeing. So I'm going to go 4 to the negative 1, and then it's still to the x power. Okay, equals, and then 16 is 4 squared. So this is 4 to the negative x power equals 4 squared. And so again, once we have our bases the same, we know that our exponents must be the same. So that means that negative x must be equal to 2, which means that x equals negative 2. Okay, so then I know that my log 1/4 of 16 equals negative 2. Okay, and that's how you evaluate these. You cannot just plug these in a calculator because most calculators don't calculate logs with bases other than e or 10. Okay, so that's how we have to evaluate our logs without changing bases. We'll learn about that a little bit later. So again, what does this equal? So we have I have 3, right? 3 to the x power, that's my exponent, is equal to what result? 0. Okay, well, this is base here 3. I can't get this base to be the same, right? And so this is 3 to what power equals 0? Nothing. It's undefined. Okay, so this is undefined. All right, So remember that right here, it always says that my b must be greater than 0. Okay, so keep that in mind. Okay, otherwise it's going to be undefined. So there's nothing I can raise. So if I put this the 0 power, that would be 1, right? And so there's nothing that will give me 3 to the x power equals 0. So remember that we can't take any logarithm of 0. All right, it's undefined. Okay, how about this guy? So what would this be equal to? So 2 to the x power equals 2 to the 8th power. Okay, now we're going to learn some properties about this guy in a little bit. Okay, so this is going to become 2 to the x equals, we'll go back here. Don't need to do that because we already have the same bases, right? So we have the same bases, then x already equals 8. Isn't that fascinating? So you have 2, the base to the same b here. Automatically we know that 8 is equal to x. So that's kind of a cool little property to remember. Okay, so if we have a base that's the same number as this guy, we just automatically know that 8 equals x. Okay, so keep that in your back pocket. Okay. All right. So how about this guy here? 5 base 5 is what? Oh, let's check that out. So 5 to the x power equals 5. So 5 to the x power equals 5. That's the first power. So x must be equal to 1. So that must be equal to log base 5 of 5 must be equal to 1. So anytime we have just a base with the same number, it's a logarithm of 5. Okay. Or excuse me, logarithm of 1, which makes sense because this is like the one we did before. That's a power of 1. So back here, it was a power of 8 with the same base in b, it equal to 1, or to 8, right? So this right here was log base 2 of 2 to the 8th power just equaled 8, that same exponent. This is the same thing, it just is equal to that power of 1. Okay, so watch for that when you end up having the same base in letter b. Okay, it ends up being that same exponent. Okay, so you might want to shut the computer video off here and try this on your own and come back and see how you do. Okay, so what does this evaluate to? Okay, in other words, what 3 to what power gives me 1 over 81? Well, I have a base 3 here, so I'm going to leave 3 to the x equals, and I'm going to bring this to 81 to the negative first power. Okay, 3 to the x equals, so 3 times 3 is 9, times 3 is 27, times 3 is 81. So that's 4 3s. So we're going to go 3 to the 4th power and times the negative 1 that's already there. So this will be 3 to the x equals 3 to the negative 4. Okay. So now we have our power of x equals negative 4 because we have the same bases, right? So x equals negative 4. So we know now that my log base 3 of 1 over 81 equals negative 4. Okay, how about this guy here? So this is kind of the same except it's negative. So let's see what we end up getting here. All right, so we have 7 to the x power equals negative 7. Let's see here. So what power gives us negative 7? It really doesn't work, does it? So you remember that rule back here. Let's go back here where b has to be greater than 0. It can't be equal to 0 and it has to be greater than 0. Okay, so this again is undefined. Okay, that's kind of a weird one, right? There's nothing we can put in for power of x that will give us a negative 7. Right, it'll give us maybe 1 over 7, but it won't give us a negative 7. Okay. All right, so that's what we're going to do this for today. We're going to just basically practice writing logarithms and exponentiations back and forth, and also learning how to evaluate logarithms. Okay, you have a Google Classroom Excel, and then I will see you all in school. Bring lots of questions. Bye-bye.